Section 6.4, Inverse Functions. So as a reminder from Chapter 2, recall that a relation is simply a mapping of input values, which are the x values, onto the output values, which are the y values. And also recall that there's basically three ways that we can look at a relation. One way is an equation, and we can convert that equation by making a table of values, and then when we plot that table of values, we have our graph. And so we're going to be looking at inverse functions in all three of these ways. So in inverse relation, you're simply going to think about switching the x and the y values. And so to find the inverse of an equation, for example, and for these first examples, we're going to be using that example of y equals x squared. And so to find the inverse of an equation, you're simply going to rewrite the equation, switching the x and the y. So if our equation was y equals x squared, we're going to start by rewriting that as x equals y squared. All the numbers and everything else are going to stay in the same place. All you're doing is simply switching the x and the y. And then you're going to solve that equation for y. So in this example, to get y by itself, to undo the squaring, we're going to take the square root of both sides. And so we get y equals plus or minus the square root of x. And that would be the inverse equation of y equals x squared. For a table of values, again, we're simply switching the x and the y values. So the ordered pair -2, 4 is going to become 4, -2. -1, 1 is going to become 1, -1. And obviously 0, 0, and 1, 1 are the same either way. And the last ordered pair 2, 4 will become 4, 2. And lastly, looking at it graphically, for a graph, the inverse is the reflection of the original function across the line y equals x. So this is a little bit harder to visualize or think about. Again, we have graphed in the red the original function, and then in the blue would be the inverse function. And that's reflection across that line y equals x. So our first example, let's find the inverse of y equals 3x plus 6. Well, let's also look at these both graphically, both the function and the inverse. So let's begin by graphing that function. It's simply a line. And now we're going to find the inverse. So the first thing we're going to do is rewrite the equation, switching the x and the y. So y equals 3x plus 6 is going to become x equals 3y plus 6. And now we're just going to solve this equation for y. So subtract 6. And then we're going to divide by 3. And separating those terms, we get y equals 1/3 x minus 2. And when we graph that line, you can see that it will indeed be reflected across that line, y equals x. And you'll notice some of those ordered pairs as well. So you'll notice that the ordered pair on the original function, -2, 0, becomes 0, -2. Or -1, 3 becomes 3, -1. And so all those ordered pairs, if you identify what each of those ordered pairs are on the purple line, flip that ordered pair and you will see that graph on the green line. The next example, let's find the inverse of y equals x squared minus 4. So again, let's start by graphing that. And again, we can do that simply by plotting points. And then we can find the equation, switch the x and the y, and now we're going to solve this for y. Adding 4, we get y squared equals x plus 4. And then we're going to take the square root of both sides. And recall that when you're finding the square root, it's got to be plus or minus the square root. Now, keep in mind if we were given an equation that's y equals the square root of x plus 4, we would end up with a squared. This is going to come up in the homework, I believe. But you would only graph half of the parabola if you were doing this in the opposite direction, if your original function was a square root function. And so we'll graph this, and we can see that our inverse is going to be a reflection across that line again. Is the inverse in a function? In other words, would it pass the vertical line test? So keep this example in your mind. I'm going to refer back to this in a little bit. But keep in mind that a function, in order to be a function, needs to pass the vertical line test. So this inverse function is not a function. Inverse relation is not a function. Which brings us to the definition, another definition of inverse functions. If we're given two functions, f of x and g of x, we learned the composition of functions in the last section. And if two functions are indeed inverses, that when you compose them both ways, f of g of x and g of f of x, then you will get x. And that verifies that they are indeed inverses of each other. This notation is the notation and for the inverse, and it's red f inverse of x, and that's a little -1, so it's f to the -1 of x, but it's red f inverse of x. So let's go ahead and verify that these two functions are in fact inverses of each other. In order to do that, we need to compose them, f of f inverse of x. So the first thing we're going to do is replace that inside f inverse of x with what it is, and then we're going to plug that into x in the f of x function. So for the x squared minus 9, remember squaring and square rooting undo each other, so we're left with x plus 9 minus 9. The plus 9 and minus 9 cancel out, and so we're left with just x. However, to verify that they're inverses, you actually need to do it both ways, so we need to compose it the other way as well. So f inverse of f of x, again we're going to replace that inside f of x with what it is, x squared minus 9. And then we're going to plug that into the inverse function. So to begin with, you can see that the minus 9 and plus 9 cancel. We're left with the square root of x squared. Again, they undo each other, and so we're left with x. So they are indeed inverses. Another way that you could possibly do this is take one of the functions, find the inverse, and does it match with the other function. But if it asks you to verify that they are inverses, this is the method that you should use to verify that they're functions, inverse functions. So another thing that you need to start thinking about and getting used to doing is understanding what an equation means. So if we have this equation, s equals 1050h plus 50, where s is the salary and h is the number of hours worked, how would you describe what this equation means? I'd like you to take a minute and think about how you would describe what this equation means. And as it's kind of defined, it's a person's salary is $10.50 per hour, and that extra 50, I guess they must just get just for showing up to work. If it wants you to write the function in terms of the hours worked, what this means is we need to solve the equation for h. We're not going to flip the s and the h because that would give new meaning to those variables. So in a word problem, to find the inverse, oftentimes you're just solving for the other variable. So to solve this equation for h, I'm going to subtract the 50. And then I need to divide by the 1050. And I'm going to write this down below here. So the number of hours worked is the salary minus 50 divided by 1050. So now we can use this equation to answer part C. If a person's salary was $533, how many hours did they work? Well, we're just going to plug that 533 in for S. And when we simplify this, we can see that we get 46. However, I'm going to stress this now and again. This is a word problem. Make sure your answer has a label on it. They worked 46 hours. So let's get some practice finding some more inverse. Let's find the inverse of x to the 5th. So again, keep in mind that f of x simply means y equals. So we could, if you want, rewrite it first as y equals x to the 5th. To find the inverse, you're going to flip the x and the y. So x equals y to the 5th. And to get the y by itself, we're going to take the 5th root. So we get y equals the 5th root of x to the 5th. And why is it not plus or minus? Make sure that you can answer that question. To determine if the inverse is a function, well, we need to see if it passes the vertical line test. So if you were to go ahead and put this into your graphing calculator, you would see a function that looks like this, and it does indeed pass the vertical line test. So the inverse is a function. I want you to pause the video and go ahead and try to find the inverse of this one, and then come back and see if it matches what I have. Now when you get y cubed equals x minus 4 all over 8, hopefully you are becoming somewhat familiar with your perfects lists, and you notice, if you notice, that 8 is a perfect cube, when you take the cubed root, you could break the top and the bottom apart, and so then you would actually have the cubed root of x minus 4 all over 2. Alright, so now let's take a look at this horizontal line test. The horizontal line test is used to determine if a function's inverse will be a function. So in other words, if the original function does pass the horizontal line test, then the inverse is a function. If it does not, then the inverse is not a function. So if you think back to that problem that I asked you a few problems ago, is the inverse a function, and it failed the vertical line test? If you look at the original function, its original function would fail the horizontal line test. So let's go ahead and graph this function. We can do so by making a t-chart, recalling that the vertex is at 0, -4. And then we can see that the inverse, because it fails the horizontal line test, the inverse is not a function. But we're going to go ahead and find the inverse, flipping the x and the y. Solving this for y, we get that y equals plus or minus the square root of x plus 4 all over 2. And one last example. When we graph this one using our t-chart, we can see that this does in fact pass the horizontal line test, so that the inverse is a function. And now let's go ahead and find the inverse. So we get y equals the cubed root of x over 2. And that basically concludes our notes. Make sure if you have any questions, you're coming to class and asking them. If I breezed over something too quick, or if you need some clarification on anything, please don't hesitate to ask. And we'll see you tomorrow in class.